pentose phosphate pathway. Now this hexose monophosphate shunt or pentose phosphate pathway or phosphogluconate pathway is the alternate pathway for glucose oxidation. These three are the same thing. Hexose monophosphate shunt, pentose phosphate pathway or phosphogluconate pathway is just the alternate pathway for glucose oxidation. Now the enzymes of this hexose monophosphate shunt or HMP shunt are located in cytosol or in plastids. In cytosol and in plastids, the enzymes of this pentose phosphate pathway or HMP shunt or your phosphogluconate pathway exist. Now this pentose phosphate pathway or HMP shunt has two primary functions. It provides NADPH for reductive biosynthesis, and it also provides a ribose 5-phosphate for nucleotide or nucleic acid biosynthesis. Pentose phosphate pathway provides NADPH and ribose 5-phosphate. Now the reactions of this pentose phosphate pathway are divided into two phases, that is oxidative phase and non-oxidative phase. Now let's have a look at the oxidative phase of the pentose phosphate pathway, which is irreversible. Now this glucose 6-phosphate dehydrogenase G6DP, this enzyme is NADP dependent, and this NADP dependent enzyme converts glucose 6-phosphate into 6-phosphogluconolactone. Okay, 6-phosphogluconolactone, that is what is produced by the action of glucose 6-phosphate dehydrogenase on glucose 6-phosphate. And then this 6-phosphogluconolactone is hydrolyzed into 6-phosphogluconate, and this hydrolysis reaction is catalyzed by gluconolactonase. Okay, so you start with glucose 6-phosphate, then that is converted into 6-phosphogluconolactone, and then that 6-phosphogluconolactone is converted into 6-phosphogluconate. The next reaction involves the synthesis of NADPH, and the next reaction is catalyzed by this enzyme 6-phosphogluconate dehydrogenase. So this 6-phosphogluconate is converted into 3-keto-6-phosphogluconate, and in this reaction there is synthesis of NADPH, and this reaction is catalyzed by this enzyme 6-phosphogluconate dehydrogenase. After that, this 3-keto-6-phosphogluconate undergoes decarboxylation to produce a ribulose 5-phosphate. Okay, 3-keto-6-phosphogluconate then gives a ribulose 5-phosphate. So we start with glucose 6-phosphate, then it is converted into 6-phosphogluconolactone, then that is converted into 6-phosphogluconate, and then that is converted into 3-keto-6-phosphogluconate, and in the end that is converted into ribulose 5-phosphate. So the net result of the oxidative phase of the pentose phosphate pathway is the generation of two NADPH molecules, then oxidation of one carbon into carbon dioxide, and the synthesis of one pentose phosphate molecule. So two NADPH molecules and one pentose phosphate molecules are produced in the oxidative phase of the pentose phosphate pathway. So this is how the oxidative phase of pentose phosphate pathway looks like. You start with glucose 6-phosphate, then you convert it into 6-phosphogluconolactone, and then that is converted into 6-phosphogluconate, and in the end this 6-phosphogluconate is converted into ribulose 5-phosphate. Now in this conversion, when glucose 6-phosphate is converted into 6-phosphogluconolactone, in this conversion, one NAD plus is getting converted into NADPH. So there is formation of one NADPH in this reaction, and this reaction is catalyzed by glucose 6-phosphate dehydrogenase, and for the activity of this enzyme, Ng plus ion is required. After that, this 6-phosphogluconolactone is converted into 6-phosphogluconate, and in this reaction one H2O molecule is getting consumed, and this reaction is catalyzed by gluconolactonase. After this 6-phosphogluconate is converted into ribulose 5-phosphate, and this reaction is catalyzed by 6-phosphogluconate dehydrogenase, and in this conversion one NADP plus is getting reduced into NADPH. There is formation of NADPH in this conversion, and there is release of one carbon dioxide. So in this conversion there is formation of one molecule of NADPH, and in this conversion there is formation of one NADPH. So in total 2 NADPH are produced by the oxidative phase of the pentose phosphate pathway. When 3 molecules of glucose 6-phosphate are converted into 3 molecules of ribulose 5-phosphate and 3 carbon dioxide molecule, then in this conversion 6-NADP plus gets reduced into 6-NADPH. Now in pentose phosphate pathway, the oxidation of glucose 6-phosphate utilizes NAD plus and not NAD plus. This is the difference. So this pentose phosphate pathway is utilizing NAD plus and it is producing carbon dioxide molecule, whereas glycolytic pathway is utilizing NAD plus and glycolytic pathway don't produce CO2. And in pentose phosphate pathway there is no ATP synthesis, whereas in glycolysis ATP is the major product. So let's see the difference between pentose phosphate pathway and glycolytic pathway. In pentose phosphate pathway NADP plus is used, in glycolytic pathway NAD plus is used. The pentose phosphate pathway produces carbon dioxide, whereas glycolytic pathway don't produce carbon dioxide. And in pentose phosphate pathway there is no ATP synthesis, whereas in glycolysis or glycolytic pathway there is ATP synthesis. Now let's discuss about non-oxidative phase of the pentose phosphate pathway, which is reversible. In oxidative phase, which we just saw, 3 glucose 6-phosphate molecules give rise to 3 carbon dioxide molecules and 3 5-carbon sugars. Now these molecules, which are generated in the oxidative phase of the pentose phosphate pathway, are rearranged, and they are rearranged in such a way that the 2 molecules of glucose 6-phosphate are regenerated, and there is formation of 1 molecule of glyceraldehyde 3-phosphate, and that is your non-oxidative phase. In oxidative phase, you produce these molecules, and in non-oxidative phase you rearrange them to produce 2 molecules of glucose 6-phosphate and 1 molecule of glyceraldehyde 3-phosphate. Now this non-oxidative reactions are concerned with the interconversion of 2, 3, 4, 5 and 7 carbon monosaccharides. Okay, there is interconversion of 2, 3, 4, 5 and 7 carbon monosaccharides in this non-oxidative reactions. When epimerase enzyme acts on ribulose 5-phosphate, then ribulose 5-phosphate is converted into xylulose 5-phosphate, and when phosphopentoisomerase this enzyme acts on ribulose 5-phosphate, then ribose 5-phosphate is produced. So this ribulose 5-phosphate can be converted to xylulose 5-phosphate and to ribose 5-phosphate, and it depends on the enzyme which is present there to convert it. Now this trans-ketolase and trans-aldolase, these two enzymes are unique to the pentose phosphate pathway, and they act for interconversion between 3, 4, 5 and 7 carbon monosaccharides. Okay, 3 carbon monosaccharide can be converted to 7, or 7 carbon monosaccharide can be converted into 4. That for that interconversion, this two enzyme acts, that is trans-ketolase and trans-aldolase. Now this trans-aldolase catalyzes the transfer of 2 carbon molecular fragment, and this trans-ketolase catalyzes the transfer of 3 carbon molecular fragment from the ketose donor to the aldose acceptor. Okay, this is how the transfer takes place. From ketose donor, the 2 carbon or 3 carbon molecular fragment is donated to the aldose acceptor. Okay, the 2 carbon molecular fragment, the transfer of 2 carbon molecular fragment is catalyzed by trans-aldolase, and the transfer of 3 carbon molecular fragment is catalyzed from trans-ketolase by trans-ketolase, and the transfer occurs from the ketose donor to the aldose acceptor. The names of these two enzymes should be changed because this trans-ketolase, which is also known as glycoaldehyde transferase, transfers aldol moiety, and this trans-aldolase transfers ketol moiety. Okay, but we are using traditional names, so that is the reason why they are not changed. But you should remember this, that trans-ketolase transfers aldol moiety and trans-aldolase transfers ketol moiety. Now this enzyme trans-ketolase have thymine pyrophosphate as coenzyme. The coenzyme of the trans-ketolase is thymine pyrophosphate. So this is how the non-oxidative phase of the pentose phosphate pathway looks like. 3 molecules of ribulose 5-phosphate are converted into 2 molecules of glucose 6-phosphate plus 1 molecule of glyceraldehyde 3-phosphate. So this flowchart represents the pentose phosphate pathway, and it represents how the interconversion of 3, 4, 5 and 7 carbon monosaccharides take place with the help of this pentose phosphate pathway. So we start with glucose 6-phosphate, and glucose 6-phosphate is converted into 6-phosphogluconate, and then that 6-phosphogluconate is converted into ribulose 5-phosphate. Now we discussed, when epimerase acts on this ribulose 5-phosphate, xylulose 5-phosphate is produced, and when the enzyme phosphopentose isomerase act on this ribulose 5-phosphate, then ribose 5-phosphate is produced. We discussed this, right? Now when these two combines, that is when xylulose 5-phosphate combines with ribose 5-phosphate in the presence of trans ketolase, then pseudoheptulose 7-phosphate and glyceraldehyde 3-phosphate, these two molecules are produced. This is a 5-carbon sugar, this is a 5-carbon sugar. They are combining to give you the 7-carbon sugar and 3-carbon sugar. So if you need for any biosynthesis, if you need the 7-carbon sugar, then you can take it out from here. Okay, that's the purpose of this pentose phosphate pathway, is to convert this glucose into 7-carbon sugar, then 3-carbon sugar, then 4-carbon sugar, then 5-carbon sugar, okay, for the purpose of various kind of biosynthesis. So yeah, this 5-carbon sugar, both of them combine to give a 7-carbon sugar and a 3-carbon sugar in the form of pseudoheptulose 7-phosphate and glyceraldehyde 3-phosphate. Now, these two again combine in the presence of trans-aldolase to give fructose 6-phosphate and erythrose 4-phosphate. Okay, 7-carbon sugar combine with 3-carbon sugar to give a 6-carbon sugar and a 4-carbon sugar. So you have a 4-carbon sugar. And then this fructose 6-phosphate again gives glucose 6-phosphate, and this erythrose 4-phosphate combines with xylulose 5-phosphate, and the combination of these two in the presence of trans ketolase gives you glucose 6-phosphate and glyceraldehyde 3-phosphate. Okay, as you can see, this is a 5-carbon sugar and this is a 4-carbon sugar. In total 9 carbons. So this 9 carbons combine to give you a 6-carbon sugar and a 3-carbon sugar. 6 plus 3 again 9. So this is how the interconversion of 6-carbon sugar to the 5-carbon sugar to the 7-carbon sugar to the 4-carbon sugar takes place. This is the flow chart which is representing your pentose phosphate pathway.